Okay, so we've been studying rate of change for a few years. We just put average rate of change. You remember the formula? The slope formula, but we have calculus notation. That works. Slope formula. That's for points. 2 points, x f of x and a. That's the slope formula, right? Average rate of change. It just connects the dots in a straight line. I've mentioned instantaneous rate of change, right? We talked about that. Okay, so. Are you okay if I just put this? It's faster. So, instantaneous rate of change, aka the derivative. Here's one of them. So limiting this as x approaches a makes it an instantaneous rate of change. Gives you a tangent line slope. See how many ways we can write this?
Isn't there also one line?
You can write it like that. I write it like this because it shows the relationship between average and instantaneous. But what's the other derivative definition? Logan Waterman, do you have this memorized? You might want to pay attention. So there are lots of ways that we say the same thing right now. No. We're just going to get used to it. Actually. Okay. Are any of you in physics? No. Oh, the tragedy. Calculus based physics is probably the coolest class ever. Yes. Here's an example. This is going to show you the relationship between a few things. So the truck enters an off-ramp. From the highway at, that's not what I want to say, t equals 0 times 0, okay? Its position after t seconds is S of t equals That should be cute. Meters. We float around in the metric system. Or 0 E.
Is that 25 T or 2
25T minus 0.3 T cubed. Okay, so we have our information, right? How fast? Is the truck going when it enters the off lane? Very good question. Is this instantaneous or average rate of change? Yeah, it's at this exact moment. Right, it's one spot in time. Average is 2 spots in time. This is instantaneous rate of change. Okay. What do we know? If we have a position function, what do we do to get instantaneous rate of change? Take the derivative. And then we'll evaluate it at what time? At 0. Okay, so S prime at t, 25.
Did you just find the derivative?
How to take the derivative. This is a position function.
But you're not using
You want rate of change, you need instantaneous rate of change, you need derivative. This is cube.
Oh.
So bring the 3 down, you get 0.9, subtract 1. And then at time 0, $25 what? Per second. No, it's the speed. Okay, we're not to acceleration yet. How would I calculate acceleration at time 0? Question of the day. You don't have to know it yet. You can. Very easy. Acceleration is the rate of change of speed, correct? So what do I do to that? The second derivative gives me acceleration. So, yeah. So if you, this is actually Thursday's work that you asked. So, why would you?
No, I just told us.
Acceleration is the second derivative. So, yeah, double times. Over back. Okay, what's the derivative of 25? 0. And what's the derivative of that?
Negative 1.8.
Times 0 is actually not decelerating or accelerating, right?
So that's the right.
That's right when he hits the ramp, his foot's still on the gas pedal. So you're seeing the relationship here between position, velocity, and acceleration. derivative, and you do it again. Okay? So you just take derivatives. Well, next semester, you start at acceleration, and I'll show you how to go backwards. It's not that difficult. All we're doing is going forward. So if this is usually denoted with S of t, you'll see this one as S prime at t, or they'll call it velocity of t sometimes. Acceleration would be S double prime, or velocity prime, or A of t. So those are some of the ways we notate these. For now, all you have to do is go this direction. Okay, so read the question, figure out what you have to do. Is the truck speeding up or slowing down?
I'm going down a second.
Is it? What's happening to the velocity? When the truck comes off the off ramp, obviously we have to slow down. Right? That's what intuitively makes sense. How can you explain that mathematically? What happens when acceleration is negative? Okay, that would be one thing. You could explain that, right? It's always negative. Time is not negative, right? So you have a positive times a negative. Okay. So there's one way. And that's one explanation. Acceleration is negative. How could we use this function to describe that? What's happening here? The constant and then you're subtracting from it. What do we call that mathematically? Decreasing? Somebody said it. You said it. Okay, so velocity is always decreasing. D. How do I know that? You're just taking away every time, right? 25 and then you minus 0.9, and do minus 3.6, and then you minus again and minus again. It just keeps going away. So does this kind of make sense? Again, you're just using derivatives for rate of change. You get position, the first derivative gives you velocity or speed. We'll get into more specifics about the differences. Second derivative will give you the acceleration. For now, you're going to get a ton of these this year. You could say a particle has velocity t squared minus 5. What is its acceleration at time 4? They're all going to be structured like this. You just have to figure out which derivative you need and what you need to plug in. Let's look at a geometric example. Do you agree? Circle area is pi r squared. I made that up. That's why my name is inscribed in history. Confused? DAVR So this in English, this is saying compute the change in area with respect to the radius. That's what that's saying. The area is changing and so is how is it related. That's what we're looking at because we're in movement, right? How would I calculate that? All right. Have the area. What is DAVR? Derivative. So, what's the derivative with respect to R? 2 pi R. You just take the derivative. It's a change. Instantaneous. And then we're going to evaluate it too. So you would write it like this. Should we get into the finer points of that? R equals 2. Yeah, so we're saying we're evaluating it when R equals 2. That's mathematics. The funny thing is the surface area and volume formulas for a sphere, same thing happens. The same. If you take the volume, 4 times pi r cubed, the derivative is 4 pi r squared, which is the surface area. So, it's good. Neat stuff. Okay, what is it at 5? 25? Right, so I just did 5 now. Why is it 3? I don't know. Yeah, I looked at some of you and were like, okay, why is 10 pi bigger than 4 pi? Good question. Why is the rate? Remember, this is the rate. It's not the size. We know the size is bigger. But why is the rate? Why is it growing faster? Why is the area growing faster at 5 than at 2? Usually both have a good explanation to say about her. Yeah. It's squared. Yeah. Right. So that's going to mean that the area changes as a square of the radius. Okay, so that's why this rate of change is bigger. This is like going 100 miles an hour versus 40 miles an hour. Because of that square. You gotta start thinking those terms. I'm gonna throw a penny in my knee. I'm awake. Close your eyes. If you were asleep. I have a headache. Okay, so these are the two we wanted to look at today. The position, velocity, acceleration, instantaneous rate of change, and then the circle area rate of change. Okay. They're both instantaneous. We're using derivatives. Any questions? Okay. Through 11. It means don't do 9 to C. Unless you want to. So, yeah, just do 9 A, B, and then go to 10 and 11. Yes, you know it.
Had a paper in front of me. I gotta put it on.
Trying to get you practice, huh?
I still want to know.
I know there's a volleyball games tonight, so if you need an extra day, just say so. We'll check it tomorrow. The key here of these is getting the practice. Women's practice, first 3 sections practice. Tomorrow we'll do 3, 4B, then Thursday 3, 5. I'll be gone Friday, you have a quiz. Let's do a quiz Friday.
Are you on Thursday and Friday?
What?
Are you on Thursday and Friday?
No. Well, I was going to be, but I don't. I'm taking Friday off for my own personal sanity. Because I don't need to, I shot a deer this weekend, so I don't need to go look for deer anymore. I'm just taking Friday off for my own personal sanity. I'm wasted right now. Got a couple deer in the truck this weekend, it's good. Now I don't have to take Thursday off.